Okay, my name is Marti Bolivar. I was supposed to do this talk with my colleague Carles Cufí, but he couldn't be here at the last minute, so he's in the ether somewhere, and I'll kind of introduce the talk, and then we'll sort of take turns. So I'm just curious, how many of you have submitted a patch to upstream Zephyr? A lot of you, awesome. How many of you have had that patch merged? Pretty much the same ratio. I love this. Okay, excellent. Well, you're done. Great, I did a good job. Everybody here already knows this material. No, I'm just kidding. Okay, so this is what we're going to do. We're going to talk about kind of what we expect you to already know before you upstream, what you want to upstream, how to upstream, and then kind of how to deal with the cranky maintainers like me. So who are we? Myself and Carles in the ether. We were the release managers for Zephyr 3.1, which just came out this past weekend. We both work for Nordic Semiconductor. Carles is working on Bluetooth, documentation, the shell, and West. I work on device tree, West, and the documentation. So I thought we could do a talk on how to get your patches merged kind of right while we were fresh from having merged a bunch of patches to kind of keep everything at top of mind and see if it would be useful for the community. So with that, I'll hand it off to Carles to talk about the prerequisites.
Hey, so I just quickly double check that everybody can hear me well, both online and on site. All right, good. All right, so prerequisites. When we talk about prerequisites here, we're referring to what you need to know before you attempt to contribute code to Zephyr. So in general, Zephyr is a welcome community, meaning we don't mind if the process for you to submit a patch is also a learning process for you. And we are generally very happy that people actually come and try to submit code and make an effort to contribute to Zephyr. So we like to think we welcome people with open arms. If that's not the case, please let us know, because we're there for the good and for the bad. So anyways, what should you know at least when you try to submit a change to the code in Zephyr? So for starters, you should know how to code. You should know how to program in C, typically, although there is also quite a fair amount of Python code in Zephyr, so it's either C or Python for the most part. That obviously we're not ever going to or sort of go into detail during the pull request or anything like that, unless it's a quirk or a very special feature of the language. So the next thing you need to know is Git. Now, Git is the main tool that we use to manage source control. You probably either have heard about it or are using it already every day. And you do need a fair amount of GitHub skills to successfully contribute patches to Zephyr. Mainly, obviously, the basic setting up and being comfortable with creating commits and branches, mostly because you're going to be asked to format your code in specific manners, and we're going to be going into detail about that in the next slides. But also, you're more than likely going to be asked to modify the commits you've already presented to the reviewers, and for that you will need to know about rebasing. Now, you don't need to be a rebasing expert, because the workflow is actually relatively easy and relatively repetitive. So it's not something that you don't need to be a wizard, a rebasing wizard, because rebasing can get really complicated. But interactive rebasing and conflict resolution, so basic rebasing, that's something that you will need to learn. Finally, interacting with remote servers, obviously, because for the most part, you're going to be doing this via GitHub, because that's where we host the Zephyr project. So obviously being able to fork the Zephyr repo itself or any of the repos, and then keeping your branches synchronized between your local copy and the remote, which means pushing, pulling, fetching, resetting to a remote branch, and so on. And finally, opening pull requests, which is something which can be done from the command line, either via a link that typically GitHub gives you every time you push to a branch on your fork, or there's even a command line tool specifically written for GitHub that's actually pretty good, and that allows you to interact with GitHub directly. Or obviously you can also use the GUI, the web GUI that GitHub provides to open the pull requests. Finally, the last requirement is to be able to speaking English. The reason is that although we are happy to discuss in native languages privately, the Zephyr being an open source project, we want everybody to be able to understand what's going on a pull request. We want everybody to be able to contribute. So if we switch back to a language that's not a universal one like English, like it or not, it is what it is, and English is the vehicular language today for technology, and that's what we use. So you don't need to be Shakespeare by any means, or not even be fluent at it. You just need to be able to communicate in a way that we understand what you say and you're able to understand also what we say. So probably not Google Translate, but not Kurt Vonnegut either. So somewhere in between. And I think that covers the prerequisites. So with that, I'll hand it over to Martí to continue with what to upstream.
So you may not be sure if something is upstreamable or if we're interested in it. And I thought we could talk a little bit about things that we are definitely interested in having upstream and other things which we're maybe potentially interested in having upstream, but you should probably have a conversation with us first before you try it. So many things are interesting to upstream Zephyr. New hardware support is a big one. Any enhancements to anything that's in the repository are welcome. If you fix a bug, like, great, that's less work for us. Documentation, of course, and the samples are a little bit out of control, if I'm going to be honest with you, but so, if it's helpful. So that helpful sample is very important. Please make it helpful. Those are all great. Send them on. Things you should ask us about. If you've got some third-party code that you want to integrate, we have a module system. We have West. It's a way to fetch from other places. But the process is a little stricter. Generally, the technical steering committee is going to need to look at what you're proposing. There's going to be license questions, all that stuff. So if it's third-party code, just ask. Hop on Discord, send mail to Devel. We'll help you out. And then anything involving binary blobs, a lot of times there will be some driver layer that you want to add support for, but your SoC might only have a proprietary backend for it, and you're not able to, deliver a fully open solution. There's a little wiggle room there, but it's very complicated, and you should definitely have a conversation before you give it a shot. So I'll pass it back to Carles to talk about how to structure your commits.
Right. So before I begin talking about commits, I just want to make a very important distinction between commits and pull requests here, because this confuses people often, especially if they come from another Git hosting mechanism or another source control revision or source revision control program completely different from Git. Now, a commit, it encapsulates a change. Now, as you can see on the slide here, what a commit is defined to do is one single thing. Not multiple ones, just one. Along with a commit, there's the change itself, but also a commit message, which describes what the change intends to do or does. Now, it is very important, and we'll look at different commit messages. You spend some time on that commit message, on making sure that the commit message is helpful. And by helpful, it means it makes it easier for the person looking at the code further down the line, looking at that particular commit, which is something that happens a lot, more than you'd think. To be able to understand the change quicker and easier, thanks to the commit message. Now, going on with or focusing on the doing one thing mantra. So one thing means really one thing. It means that if you're combining two separate areas, even if changes seem completely benign or unimportant, like fixing the alignment, we'll go over that, you should split that into its own commit. The reason for that is twofold. One is to make it easier for the reviewers to review the code, because reviewers will typically go commit by commit and not pull request by pull request. And that's where I wanted to go when I started this train of thought a bit earlier in the previous slide, is that pull requests consist of multiple commits, and reviewers, if they don't, they should review commit by commit, not the whole pull request together. Now, everybody sometimes is in a hurry and looks at the whole diff instead of looking at individual commits. But for the most part, we look at individual commits. And the reason for that, as I said, is to ensure the future readability of the history of the code. Okay. Now you can use as many commits as you want. Don't be afraid to have a pull request with 20 commits. It doesn't that's not a problem. 200 may be too much. You probably want to split the pull request in multiple ones at that point. But in the dozens, that's actually relatively common. The last point I already mentioned, Marti. So maybe we can switch to the next slide. Yeah. So now, this is an example where we are mixing things. You can see at the top here, what's highlighted now, it's the actual change, the change that we wanted to make, the changes that we, oh, sorry, there's someone saying that see nothing. They're not able to see the slides, Marti, I see in the chat. Oh, they have to pin the video. Okay, all right. Yeah, and we know it's blurry. Sorry about that. But anyway, I assume that people have gotten back to the slides now by pinning Tim Arthur's video, hopefully. Yeah, so going on. So the substance or the actual change we wanted to get into the tree is what's highlighted now in red. Now, at the bottom, you can see other changes. Those changes are not related. They're actually cleaning up some white space or some alignment issues that were there before. Now, this should be separate commits, because then when I go commit by commit, like we see now in the next slide, I'll only see the actual change. So my brain will automatically switch to concentrating into what's going on there. And I will be in a much better position to reply whether I think that change is relevant or not. And I will not be wasting my cycles looking at code that it's not there. If you look at the next one is the commit corresponding now to the fixes that we were talking about earlier about alignment and style or cosmetic changes, right? That's another commit, a separate commit where we're saying, okay, fix the style on already existing code. These, as mentioned, always separate, always one goal. And it's very tempting, I know, to bundle things together in one commit, but it's really important that you don't do that. All right, moving on. So, Marti, can you send me a bad commit?
So, hey, Carlos, I fixed the bug, but then I ran Clang format on the file because I liked it better the way that my Clang format looked. So there's like one line of relevant changes, and then there's like 1,000 lines of white space. Can you review that for me, please?
Sure. And now I take a look. I look at the diff. I go commit by commit. I click on the main commit with the change that I'm interested in, and suddenly I see dozens, if not hundreds, of line changes. I said, okay, this is too long. I don't have the time for this right now, so I'll get back to this later. And I completely forget it. Said, and I replied to Marti, all right, look, the overall gist of what you're doing, I think, is all right, though it kind of became a bit blurry with all the changes. Please split your commit so I can see it more clearly.
Okay, got it. All right, well, here's one commit that just has the actual fix. And then you can skim over these white space changes in the second commit.
All right, that looks good now. Thank you. However, we would have saved ourselves some time if you had formatted this in proper commits earlier. It's a shame, but it's merged now. All right, so moving on, the commit messages. It's very important to understand that the commit message is actually split in 3 distinct sections. The first one has the one-line short log. That's what you're going to see when you, for example, do a git log -- one line. So it's the summary of what the commit does. And in the case of Zephyr, we actually enforce this format that you can see here on the screen. So subsystem, colon, and then the summary of the change. That's not limited to subsystem itself. You can chain those and put subsystem, colon, subsystem, and then summary of change and so on. But the idea here is that you have a very, very short summary. I think it's the current limit is 70 characters or 80 or so, something like that, that explains what the goal of the commit is. Then you have a middle section, which can be really as long as you want. In some cases, this can be fairly long, that describes the details of why this change is being done, not what, because what you can say on diff, especially if the commit is well formatted, right? Because that commit only contains certain changes that you're interested in. So you can look at the diff, and this is never going to be a replacement for the code, but you can say why. And finally, the last line is a signed off by line. Now, this has legal implications, and you can read more about it in the official Zephyr documentation. Essentially, that means that this code has been written by you, and that you acknowledge it, sending it to the open source repository. So next. let's take a look at a couple of commit message examples. The first one, it's a little bit difficult to understand what things do if you don't have a full overview with the first line. So, like for example, in this case, this is a relatively good example where you see subsystem, then subsystem indicates which device you're modifying the driver for, and then what it does, right? It factors out the bus I/O routines. Now, then the middle section, let's see if it really explains why and not something else. Well, it does, right? Because it does repeat that that the I/O bits of the code are moving into their own files, but it also says that this makes this driver more similar to other sensor drivers. So consistency is the reason here. That's why we're doing it, for consistency. So when a few years down the line, you look at the history of this particular file and you say, why did someone do this? Well, for consistency. At the time, maybe in 5 years' time, drivers look completely different. But at the time, you'll find out that at the time, this was the best way to get consistency across drivers. Maybe it's no longer the case, so you want to now send a commit to fix it. Finally, you have the signed off line. So this is the do's. I would say this is the do's with alongside the single don't that we've added in this slide, which is the don't just summarize, but actually explain why you're doing it. This is a bad commit, obviously. I guess by now, if you've been listening to what I've been saying, you'll know why this is a bad commit log. It only has a couple of words. It doesn't say why. It just describes what it's already doing. It's not helpful at all. Let's look at the good one now. This one says fix GAT network ID advertising. So you know that during the advertising, which is an operation you do with Bluetooth Low Energy, there's an ID that's being sent to the advertising packet, and here you're fixing it. Then the middle section, the body of the commit message explains that this is referring back to the spec specification where it says that you need to send the network ID in this manner. So this PR or this commit in this case aligns the implementation with the spec. So that's why the implementation was not aligned with the spec. And finally, the signed off line. It's self-explanatory. Moving on, you can see here the process by which a good commit log can help. So for example, let's start with Martí. Again, sending a bad commit log.
Here's the fix. I fixed it.
Well, I look at the commit and what is this? Why did you do this? Is that a bug? What? I mean, I don't understand. I see some changes, but I don't have any explanation attached to those changes.
Oh, yeah, no, I'm sorry. Yeah, actually, if you check this section of the Bluetooth spec, you can see that we're not handling our IDs properly. So if you look at the diff, which I know you're going to do because you're just going to look at the diff, you can get all the details. But what I'm trying to say here is that actually this is making the ID handling match up with this section of the spec. So could you take another look at it? Sorry about that.
I will. Now that I see what you wanted to do in the commit log itself, now I'll look at the code. Thank you. And approved. I'm
going to talk about branches now. This is what's in a good branch. A good branch has linear, well, okay. Many people have their own views on what a good branch is. I don't want to say that, you do you in your repository. This is our house, our rules. We would like to see a linear history. We would like to see an absence of what we're going to call fix-up commits, and since that's not a widely used term, we're going to define that. And finally, we only want to see relevant changes, right? So a pull request, a commit does one thing, but it's kind of like a subtask, right? And so a pull request does a larger thing, and you can break it down into subtasks, each of which is a commit. But the pull request should be doing something, right? If I'm going to mix up, if I'm going to hack up a new device tree API and then send a bunch of changes to Bluetooth, those are two different commits, and they're in two different pull requests in two different branches, right? So that's what I mean by relevant changes only. Okay, so linear history. If you've never run the program gitk, it's awesome. Check out gitk. It should look like this. When you run gitk on your branch, you should see a nice line where every commit has a short log, and every commit has one parent. So that's linear. That's a linear history. Now, let's suppose that you're in the Linux kernel and you run gitk. Don't do this when you submit patches to Zephyr, please. We will reject them. And here's why. So anywhere, in any successful open source project, and we're really grateful to you, the community, for the success that we're having, and we're really looking forward to the future of Zephyr. But the fact is that review bandwidth is very scarce. So by using your commits to tell a story, and by using a linear storytelling strategy, you can make your intent known to us more clearly. And that will help us understand more quickly. And that will get your code in faster, or it will help us tell you, well, actually, no, it should be like this instead. So that's why. Kind of some maybe, when we were in high school and we learned how to write like the 5-paragraph essay, that's like a pretty common thing, at least in the high school that I went to. They teach you there's like this structure that you should kind of adhere to. Here's a recommended structure for a lot of larger pull requests if you have a bunch of commits. We would like to see any prep work first, because that's usually really easy to review and it kind of warms our brain up. It helps us like kind of reestablish context in the area of the code. Maintainers are context flipping constantly. So like send your style fixes, send your refactors like at the beginning of the pull request. And then do the main sequence, fix the real bug, add your new subsystem, take over the world. That's awesome, thank you so much. And then when you're done taking over the world, congratulations, I bow to my new overlord, then you can do the cleanup. Then you can, sweep away the corpses of your defeated enemies. That will be, in this case, removing old code, deprecating anything that you've made a better solution for, right? So if you have a new API and you want to deprecate the old API, don't deprecate the old API and then add your new API. Add your new API and then deprecate the old API. Now I'll talk about fix-up commits. This is what it will look like on GitHub when you are committing the sin of making a fix-up commit. So you'll say, cool, here's my cool driver, I added it in one commit, and then you'll build it again before you submit, and you'll notice that it doesn't build because you have a typo. Okay, cool. I'll just stack another commit on top that fixes the build. That's a fix-up commit. That second commit is what I'm referring to as a fix-up commit. Don't do that. Please, don't do that. Remember that each commit accomplishes a task. So if your first commit is adding a driver, but the driver doesn't build, then the task is incomplete. And it's not a commit yet, or it's not a good commit. So please don't do that. Earlier on, Carles talked about rebasing and how interactive rebasing and editing your branches is kind of table stakes, right? We expect you to know how to rebase before you come to us with your pull request. So squash your fixes in your fix-up commits appropriately before you submit. And there are many reasons why. One is just that it's more readable, right? If we're going to review your patches commit by commit, rather, we're going to look at the diff, and then maybe your reviewer is going to say, oh, that's a typo, that won't even build, and then they'll think, how is this tested? Like, who is this person? Why are they submitting code that doesn't even build? And then they'll click to the next commit, and then they'll say, oh, there's the fix. And you've kind of wasted their time at that point. And that's not great. The other thing is that you are wasting the time of anybody who's trying to debug an issue later and they're trying to use git bisect. So for those of you who may not have heard of it, git bisect is an amazing feature of Git that lets you do a binary search in history, which is another reason why linear history is kind of nice, to find the first commit at which a behavior changed. And so if you have fix-up commits in your history, then certain commits may not be testable, especially if there's a problem with your branch and somebody's trying to dig down exactly what commit caused the problem. If you break bisectability by introducing these fix-up commits, it makes their job harder. And honestly, that they may be you, right? So make your own life easier. Don't make fix-up commits, please. Of course, like any good rule, there are exceptions. And not everything is going to be fully polished and ready for review, and a lot of times people want to just get early feedback. So that's fine. You can definitely open a pull request which has some kind of half-baked stuff that you're tacking onto as you go, as you're collaborating with somebody else. Just open it as a draft. That's a GitHub feature. You can open a draft pull request, and we're going to see, oh, it's a draft. Like, I don't have to review this with the same level of stringency that I otherwise would for something that's actually being proposed for merge right now. The other thing you can do, because I think you can't make a regular pull requests back to draft, so you can make bread into toast, but you can't turn toast back into bread. So you can put, if you decide, oh, I probably shouldn't have taken that out of draft, like after the fact, that's okay. Just put RFC in the title, and we'll know what that means, and it'll be fine. Nobody's going to yell at you. Okay, so that's all I have to say about branches. Back to Carles for information on how to respond to feedback.
Right. Thanks, Martí. So one of the things you'll notice is that most of the time, once you post a pull request, you open your own pull request, and now suddenly nothing happens. That's relatively common, and we'll talk about getting people's attention in the next section. But what if people do respond? And that's also quite common, thankfully, otherwise we'll get nothing merged. But what I meant by that, by this leading comment, is that you can't expect people to review your PR immediately after you post it. These reviews take time. And so the first thing you need to do is to wait, simply wait. Now, once people start posting review comments, you'll notice that in general, they will ask you to change things, or they will ask you why you're doing certain things, maybe because it's not clear enough from the code and from the commit message, or because it's simply just complex and they need additional explanations. So it is very important that that you read all of this feedback constructively and accurately and carefully. Now, there is also, aside from human beings looking at the code, there's also CI, which will run a series of tests on your code and on your commit messages, by the way. And obviously that will be reported, and you need to look at that as well, because otherwise it'll probably, well, you won't be able to merge the PR. So moving on to the other part of feedback is when you get feedback in the form of change requests, then as Martí just explained, you don't want fix-up commits. So what you want to do is take your branch and then create as many commits as you want locally. But then once you're done and you think, okay, now I think I've addressed all of the review comments that have been posted, now that's when you rebase. And rebase in this case means take changes from multiple commits and squash them together in the number of commits that you think makes sense for the reviewers to look at. So, and that's what will make the reviewers' lives easier, and therefore your chances of getting the patch merged higher. Now, rebasing also can be used for another purpose, aside from squashing your own commits, is to actually update your branch with the latest from main. This happens often when you suddenly realize that your change depends on something else that has just been merged. That happens sometimes, especially if the review comments tell you why don't you use this other macro, for example, which has now just been merged 2 days ago, but you had opened the PR a few weeks ago. So now you need to update your own copy. For that, you also rebase your changes on top of the latest main. So rebase actually effectively accomplishes two tasks in the review process, which is to reorder or refactor your commits and update your local branch with the latest from main. Very important, do not close the pull request and open a new one every time. That's pull requests are eternal on GitHub. You cannot delete them. Just work your commits. Pull request is just basically an ID. You can rework it entirely by just rebasing and then force pushing. Next, we have getting attention, right, Martí? This is very important. Please listen attentively.
Thing is that this can take time, and right now, at least in practice, the way I think of this is that it's optimized for throughput, not latency. So, like I said, reviewers are probably context flipping quite a bit, and they're trying to get through as many pull requests as they can in the amount of time that they have allotted to do review. Right? Some people have more time allotted to them than others. Right? Certain people's employers only give them so many hours a week for upstream work. Right? So people are just going to smash out whatever they can. And then, they may not get back to you for a while, and that is the best we can do. That's the most we can give you. So, please be patient. In addition, some maintainers are volunteers, so they're doing this in their spare time. People obviously have kids. People have things that happen in life. So, just know that not all maintainers are even being paid full time. And paid maintainers do have their own code to write. We are employed to work as open source maintainers, but often that comes with an expectation that we're also contributing things that are valuable for our company. And I think that's good overall, because it means that there is a maintainer when there otherwise would not have been one. But please understand that sometimes we have to focus on our own tasks. And it's, it's not that your code is bad, it's just that we have our own, we have our own paychecks to earn. And finally, just, review is hard. If you haven't done a lot of review, especially in an open source context, it's kind of a truism that projects reviewers are a little tired. It's difficult. You think of like the fact that most of us are introverts in this career, and now we've got random incoming, requests from new people, especially, if we don't know you, we're having to think about our, different personalities and, different areas, and it is difficult work. So, please be cognizant of that. So here's some ways that you can get our attention when you need it. So come and join our Discord. You can load chat.zephyrproject.org and you'll get a relink to the right place. You can go to a relevant weekly meeting. If you go to the wiki on the Zephyr repository on GitHub, there's a list of meetings, and you can kind of see which one is most relevant to you. So then you can just join it. They're on Microsoft Teams. They're open to everybody. There's no closed meeting in these weekly meetings, except for certain like high security vulnerability type things. Those are closed for obvious reasons. But most of them are open, and you can join. You can email us. You can, hey, come and talk to me during the coffee break right after this talk, or any other maintainer that you happen to see, right? You can send us drafts, and if you do work for a member company, talk to your company's representative. They may, they're probably going to these meetings, and they may know something relevant to your pull request. And so just talk to them. They might be the best person to connect you to the right maintainer, or maybe there's, maybe there's like a gap there, or maybe, many things happen, right? So these are great ways to get attention for your awesome pull request that we are very happy that you're submitting. Now, please don't ping us incessantly. Carles is my boss, so it would be stupid of me to do this, but like, let's pretend he's the maintainer, and I'm like, hey, Carles, I need you to review, you're probably gonna get sent where? To the front of the line? Is he gonna be like, awesome, I'm gonna give this guy my time? Probably not. We're all human. And, for the same reason, please don't be rude, just for obvious reasons. All right.
Yeah, usually
now, because review is a personal activity and disputes are inevitable among humans, I'll turn it over to Carles to talk about how we try as a project to resolve them.
Indeed. And going back to your comment, Marti, this please, incessant pleading to get something done doesn't work with my son. It's not going to work with contributors either. It's as a parent, as a maintainer, I always insist people respect the time of their elders. So moving on to resolving disputes, dealing with maintainers. So maintainers in general are responsible for the quality of the code in their subsystem. So that's why they insist for changes. They're not there to make you unhappy or be or nitpick just to have fun. They do that because it is their own responsibilities that the code looks good and that it does what it needs to do. So now, while you have to respect the rights for maintainers to request changes from you, they are wrong sometimes, or there's simply no wrong or right answer sometimes. It's just there's a dispute, there's a discussion, and the maintainer has an opinion, and you as a contributor has another opinion, and that's fine. The maintainer does not have to be right. The maintainer may have more experience in that particular area than you do, maybe, or maybe not. But the point is, the maintainer is another human being and another programmer, and they're not always right. So the best thing to try and resolve this is to talk to them. Talk to them with any of the means that are available to you. So in the next slide, we can see a quick list of what we have in terms of means to communicate with us and with anyone really among everyone. So you have GitHub, obviously the pull request itself. That should be the first place to discuss these things, but sometimes you want immediate feedback. For that, Discord is usually very useful. Now, some maintainers are more present than others on Discord, but in general, they're all around. So that's very useful as well. Then there's mailing lists. They're not typically used to discuss pull requests, but there's nothing forbidding you to do so if you feel comfortable this way. So that's perfectly fine. Then we have specific meetings to discuss these or issues in general and pull requests and disagreements and discussions. The dev review on Thursdays and the API meeting on Tuesdays, and you can use those freely. Contact the organizer in question, and they will include your item in the agenda. And finally, at conferences, unfortunately, I couldn't be there this time, but I usually am. And Martí, who knows more about Zephyr than myself, he's around, so you can ask him about anything you want, and I'm sure he'll be happy to discuss it with you. Finally, there's the TSC. Now, the TSC is the Technical Steering Committee, for those of you that don't know about this. And essentially, we have their formal mechanism for voting on things. There's an established quota of votes per company, and there's also community representatives. It's all formalized and so on. So if you really need to take this to the final decider, the TSC is the way to go. And again, anyone can raise items for the TSC to discuss. You don't need to be a member. You don't need to pay any money. You don't need to be known. You don't need to work for any company. You can be in your own room doing whatever you want with Zephyr. And if you're right, you'll probably get away with your change, and that's fine. That's how it should be. So now do keep in mind that the TSC should only be reserved for cases that cannot be solved otherwise. And that's it. And then, Martí.
Thank you so much. We are so glad to see all these patches coming in. We are seeing a lot of patches come in. So please help us save time and help get your code merged as fast as we can. Thank you so much. Have a great rest of your conference.